Hey folks, welcome back. This is Joel, and in this series we have been discussing about Aruba's SD-brand solution. We have discussed quite a lot of topics in this series, right? We'll do a quick summarization, at the end of the video. But to get started, in this particular video, we are trying to explore the various redundancy options which are available at the branch side, right? So let's go on to the topology. Grab my screen here. Okay, so basically what we'll be doing is on the branch side, right? So if you look at my screen here, we already have the branch gateway 1 which was already brought up in the past. We'll try to get this second box up now, right? And once that box is up, we'll obviously do its bootstrapping. We'll configure it, all the minimal configuration which is needed. We will not enable orchestration, the overlay and stuff. All we need to understand is how to build the redundancy, right? So for now, what we'll do is we'll just bring up this box, and then once we have brought up the box, what we could do is we'll explore how we can do things like the uplink sharing, right? That's a very interesting concept. What happens is we will go and shut this link. We'll shut these two links. So from the BG1 gateway, we are going to shut the MPLS link, and on the BG2, we'll shut the internet link. So by doing that, what will happen is this guy will just have one uplink, whereas this guy will have just one uplink, right? This uplink will be towards internet and this uplink will be towards MPLS, right? Now in this scenario, how do you share the uplinks? That's a very interesting concept. How can you share this internet, right, with the second guy? Because this, we have shut this link, right? So is there a way where it can share the link? Yes, there is possibility, right? Remember, we did similar concept in Cisco's Viptela as well. We called it T-lock extension, right? So here, how these guys do is they end up creating a tunnel here, right, between these two boxes. So you're gonna get a GRE tunnel over here, right? So, and for peering all of that, we'll use a separate VLAN, right? We'll use a separate LAN side VLAN, but basically ultimately you'll have a GRE tunnel between these two boxes. So by doing that, we will have a physical uplink, which is the internet, whereas you'll also have a virtual uplink through the tunnel, and traffic will go like this, right? If you want to use the MPLS, you can use the tunnel and then send the traffic to the MPLS, right? That MPLS uplink of the second box. So that's a very interesting concept, where ultimately by doing that, what you're doing is you're sharing the uplinks, right? Though you have one uplink, right, you're sharing that internet uplink with the other box. So that's very interesting, something we'll try to explore. I have not had much success getting that up. Sometimes sometimes it doesn't come up, so we'll try our best to get that thing configured. And finally, we'll wind this session by creating VRRP, right? So we already have set up VRRP. We have put the virtual IP, we have put the individual IPs on the BG1, but since we are bringing up the second box, we'll configure the individual IP of the second box as well, and we'll see if the master and standby sync is happening successfully. Perfect. So I think we're good to get started, right? So what we'll do is we will go and turn on this box. Ideally, when we turn on this box, we have DHCP configured on the ISP, correct? So when this box comes up, ideally it should get the IP address from the ISP, and then it should go and talk to the central, and basically it should do zero touch provisioning, right? And it should go and contact central. So once the box comes on the central, we will add it to the right branch group. So that's what I'm going to do. Let's just make sure that I have the right, as you see here, it doesn't have the right ISO file. So let me find that, 1 second. Perfect. So I found the correct ISO file. I've added it over here in the QEMU options. Make sure the QEMU is 410 and rest everything looks good. So we are good to get this guy started. So I'm gonna hit the start button on this one, right? So we can also monitor it probably from the VNC console here, but it's gonna take some time. We have observed this in the past. So I'll pause the video, and we'll be back once this box is completely booted up and it is visible on the central. All right, so looks like the box has come up, as you see here. Now we can go and have a look here. You can see, just refresh this. It still shows number as 3, but you can see all the 4 boxes are here. Maybe let's go to a different tab and then come back here, click on gateways, and there you go. All the 4 boxes are online now. So you see this is the latest box, right, ending with the serial number of 488, which has come up. Perfect. So what we'll do is obviously we'll have to move this box to the branch group. So what we'll do is we will go to the gear icon here. We will select the box which is in default group right now, and we will move it to which one? The bits branch. That's the group, right? So we're gonna move it there. Perfect. So now it will try to obviously get some configurations from the group because we have done some group level configurations, right? So let's go to the group, by the way. So this is the group, just to make sure what configurations we have. We've got a bunch of configurations of this sort. I just want to check if we have the overlay. Okay, so it looks like the overlay is also enabled. I think earlier I mentioned it wasn't. Technically I think it is enabled because we have enabled the overlay at the group level. So when this box actually comes up, it will also become part of the overlay, right? So let's see what's happening on the box. Okay, it's still very static. That's fine. Coming back, let's go to devices. Let's see if the box has moved to this group. Yeah, as you see, it has moved to the group. So time to do some device level configs, right? So let's click on the device. Let's go to device, and it is asking for us if you want to use the guided workflow. I'm gonna say cancel, exit. Let's use the old school way of doing things, right? Let's go to we are in the advanced mode. That's fine. Let's go to system, general, and here let's start putting the host name, which is going to be bgw2. That's the second box. Cancel. I'm going to hit the save. Okay, so let's wait. I think that went through, which is a good thing. Remember, for the system IP address, we have used this system IP pool, so it will get an IP from that, so we don't really have to worry. I think you can probably see that here as well. I guess we have done that at the group level, so yeah, there you go. So that's the system IP pool, so it will get the IP from that. Let's start configuring the uplinks now, right? So let's go to the basic mode, and let's go to the LAN. So we are on the VLAN now, right? So again, all of these are coming down from the group configuration, right? So for the uplink, the VLAN is the MPLS VLAN. So let's click on the pencil icon, and let's put the IP address, which is going to be, let's look at the topology. The IP is in this subnet 10.0.100.0, right? So we are going to use 10.0.100.101 because we have used 100.100 for the other guy, right? So you can put the subnet mask as well and hit the save button. I just want to double confirm what is the IP which this guy has received. So let's probably look that up on our ISP router. Okay, hit the disconnect once. So what we could do here is let's look at show IP DHCP binding. Right, so there you go. I think we have probably received, I think it's 100.3 if I'm not wrong, right? So that's the IP which we have received on the new gateway which have come up. Okay, anyway, so we just now went and put the IP address on this guy, which is fine. Then what do we do? Let's also put the IP address on the other VLANs. Like for example, why we need the individual IPs, because later we will enable VRRP on this device, right? So we need an individual IP for the VLANs because we'll have a VRRP instance per VLAN. So this guy is going to be, let's use something like 5. I think we have used 5.1 for the VRRP IP. We have used 5.2 on the other box. We'll use 5.3 here. Okay, subnet is going to be same. Hit the save button. Okay, similarly, let's go to 6. Let's select this guy. Let's go here. Let's select 3. With the IP, save, right? 7 and 8, there are 2 more VLANs here, so let's go to this guy, .3, and the save. Okay, and the last one is VLAN 8. Perfect, so hit the save button. All right, so those are the 4 VLANs. Remember, we also have a peering VLAN. Now this peering VLAN is very important for the whole like I mentioned earlier, right? We'll be doing the whole uplink sharing. So we need a VLAN between these two guys for the two boxes to talk to each other and do the whole peering, basically exchange the information, right? And for the IPsec tunnels to be formed and all of that, right? Sorry, not the IPsec, the GRE tunnels. Remember, we talked about that, how the uplink sharing happens. So for that, we need a dedicated VLAN, and we are using peering VLAN for it, right? And the IP on this guy is going to be, I think we have used 200.1 on the primary box, so we'll use .2 here, right? Subnet is going to be, as usual, 255, right? Perfect. So technically, I mean, this VLAN doesn't have to be routed. It's just a dedicated VLAN for the two boxes to talk to each other, right? And that VLAN is going to talk through this switch. We have made these ports as trunk ports, so the VLAN is going to be allowed on those ports, and as a result, the two boxes are going to be able to talk to each other on that VLAN. So we'll hit the save button here. Okay, the next is we will have to do the WAN configuration, right? So let's go to advanced mode. Let's go to the WAN links, right? And uplink. So here you see, remember, we are using the uplink utilization as the algorithm for deciding which uplink is going to be used, the load balancing algorithm, right? We're using uplink utilization. That's what we used in the other box. We'll use the same thing. And here we'll have to, okay, we'll have to hit the save first. We have to do this uplinks because only by doing this, right, we'll be able to tell the Aruba Central or the tunnel orchestrator that, look, these are the two uplinks, and this is going to be on MPLS, this is going to be on internet, so that ultimately the IPsec tunnels can be formed. So we need to literally tell the Aruba Central that this is going to be the internet or this is going to be MPLS, right? So MPLS, let's give it a name as usual. Let's use AT&T for MPLS. VLAN is going to be 3000, correct? For MPLS, make sure that the operation state is enabled, and we are going to hit the save button here. So yeah, hit the save button here. Similarly, we'll have to do the we'll have to define the uplink for the iNet as well. So let's plus button, let's go iNet, let's call this Verizon, right? And the VLAN here is 4094. That's the dedicated VLAN for the internet uplink. And rest everything is fine. Operation state is up, so I think we are good. Hit the save button. Okay, so once this is done, we should have both of these guys showing up here, which is good. Then the next is verifying. Let's make sure that our DHCP servers are up, right? Because any of these two boxes can become the gateway, because ultimately we'll be doing it as a VRRP, right? So we need the DHCP server, because when the clients come in, either of the boxes should be able to provide the IP address, right? So let's go to interface. I think that should come from the group configuration, because that's where we have done it. But just to make sure, we can go to DHCP, and DHCP server, as you see, it is enabled. Perfect. That's good. So next is we'll go to interface and ports here. Let's check if things are looking good here. Is it? I think it is not, right? So let's look at, let's start with the MPLS port. This is the MPLS port. So let's make sure that we put this in the correct WAN. It's going to be, it's a WAN port, right? And admin state is enabled. Trust, make sure it is trusted, right? Let's remove this ACL. Remember, we talked about this. I mean, not a good thing to do in production, but I'm removing it here because I like to keep all the ports, all the links without any ACL, so that I can do some ping test and all of that, right? So I'm removing that, and because we are on this, which port this is, 002, so we'll have to put this in the right VLAN, right? This is 3000 VLAN, not 4094. So we're gonna hit the save. And we can also maybe, I think that's fine, right? So that's good. Hit the save button. It'll give you this, but that's fine. I'm gonna say yes. Similarly, let's try to do the other port, which is 000, right? So the 00 port is going to be again a WAN port. Okay, the state is enabled, right? And here again, let's change this guy to allow all. Perfect, and it's all enabled, it's trusted, and the VLAN is correct, so we are good. Perfect, so we have done most of the configuration. Let's also do it from the monitoring perspective. So we'll have to go to global again. First of all, let's see if the host name and everything is reflecting, right? So if you go to BGW, click on this guy. Yeah, there you go. The host name changes and all is reflecting. You can see BGW2 is shown up here. Let's go to global and organization now, because remember we have created these sites. We have a site separate for store, right? Here you go, this one. And what I want to do is let's try to maybe, yeah, so we have created this store, right? So what we'll do is we'll try to add this new box which we just now created. Let's add this guy unassigned. Okay, it's still not reflecting. Let's wait for it. Okay, it's loading, I guess. Yeah, there you go. So this box BG2, let's go and add it to the store group or store site, right? So that it will show up in the topology and all the it is much easier to monitor, right? So like I've mentioned before, sites is very important for doing a lot of the monitoring piece, right? So you can see the topology, you can see all those tunnels, you can see all those routes and everything at the site level. Cool, so that's good. So we have done most of the things which we wanted to. Now I think we are good to go and explore that uplink redundancy or uplink sharing concept which I was talking about. Okay, just before that, I just wanted to show you that now that we did have all the configuration, let's check if the orchestrator and all ran successfully, and we can click on BG2 and we can go to WAN and you can see the tunnels and you can see 4 tunnels showing up for the second gateway as well. Right, because we did all the configuration correct, we brought up the second gateway correctly. You can see all the tunnels showing up here. If we are lucky, we should also see the topology showing up, but let's see. We go on store and we go to topology here. Yeah, there you go, right? So the second box is also showing up here. Technically it should show up connectivity to Verizon, but maybe it takes a little bit of time, I guess. Yeah, so ideally, I mean, this box also should show links to Verizon, AT&T and all the tunnels, but maybe we'll check this out at a later time. But yeah, that being said, so we are good to now start the uplink redundancy concept, right? Cool. So for that, let's first go and make sure again that we have the VLANs trusted, because VLAN 200 is very important and we need to make sure that both the boxes are trusting the VLANs, because if it is not trusted, then the traffic coming into that VLAN will, you will need to authenticate roles and all of that will come into play. So what we'll do is let's check it at the group level and the device level, right? No, in fact, we'll check it at the device level because there's no point in checking at the thing. So let's go to devices. We have done this for BG1 gateway for sure because we did that previously. Let's look for BG2, what is happening. So we will go to device, right? Security and apply policy. And you can see here for the VLAN, you can see this guy is checked, right? Which means it is trusted. Similarly, let's go to interface and let's go to ports and let's look at the LAN port, which is the 001 port. There you go. So this one, and you can see it is trusted. Perfect. So I just wanted to validate that, make sure it is trusted. Now what we'll do is we will do this at the device level, right? So we are on BG2. Let's actually start with BG1, the branch gateway 1. Click on the device, go to device. We are in the advanced mode, which is fine, right? Let's go to interface, ports. Now on this port, what we'll do first is, remember we spoke about this on the BG1. I'm going to shut this port, which is the 002, I don't want this port to be the uplink port anymore. I'm going to shut this port. I'm going to change it from uplink to LAN port, right? So in branch gateways, right, you have just two types of port. Either it is the type is a WAN port or it's a LAN port, right? When it's a WAN port, it's an uplink port. Otherwise, it's a LAN. So what we are trying to do here is we are trying to have just one uplink, right, for explaining this scenario. So we will have just the internet uplink here, and for the second gateway, we'll just have the MPLS uplink. So that basically means I need to shut these two cross links, right? So that's what we are going to. We'll go to this. For BG1 gateway, we are shutting the MPLS. So we are going to 002, right? We are going to change from WAN to LAN, okay? And there should be a shutdown. I think it should be, where is that? One sec. Is admin state, yeah, admin state is here. So we'll just uncheck it, which means we are doing shutdown on the port. Hit the save settings. As soon as you do, obviously all the tunnels and everything going through this will go down, right? So that's good. Let's do the same thing on the second box. In fact, I think I can go back one step and go and select the second box. And on this guy, we will have to shut down the internet uplink, right? Which is, I will have to shut down this guy, 000. But the good thing is, both our uplinks have connectivity to the internet, which means, you know, even if the traffic comes through MPLS or if it comes through ISP, it will have connectivity to the internet. So I think technically connectivity to central should not break, even if you are shutting one of the uplinks, right? So let's verify that. So we are on BG2. Let's go to device. Let's go to interface. Let's go to the port, which is in this case 000, because that's the internet port. Change from WAN to LAN and hit the admin state uncheck, right? Hit the save button. Perfect. So that's what we have done, right? Now the next is I think still connectivity to central should be there, I guess. Let's just double check. The boxes are still showing online. That's fine. The next thing is let's also remove the static routes which we have, right? Remember we had those I think in the underlay routing video we kind of explored that, right, where we kind of had static routes or default gateways which are set up towards both the uplinks. So which means that on the branch gateway we had a static route towards ISP and towards internet. Same thing on the other guy. Now that we have removed one of the uplink, we'll have to remove that static route also, correct? So what we'll do is we'll have to remove the static route, but we still need the static route over here, right? Because it still has the MPLS. So what we'll do is we have to remove the static route from here. So we'll remove it from the group configuration and we'll add it at the device level, right? We'll add it to the BG2. Perfect. So let's go to group, which is bits branch. Okay. We will go to configuration. And here on the routing, you can see there is a section for IP routes. You know, and that is sorry, default gateway, right? This is where we had added. There you go, this one. So we don't want this anymore. So we are going to delete this. So this is we are doing it at the group level. So once you do it here, are you sure you want to delete it? Let's actually do one thing. I'm just thinking if we remove this first, let's actually let's first actually add it on the second box, or I think it should be fine. It should be fine. Now that I think of it, it should be fine. So you want to delete it? Let's delete it from here. Okay, and let's actually go to the second box and add it, which is, I mean, we'll add it at the device level for the second box. So let's go to devices again. So because I added it, removed it from here, it got removed from where? From device 1, right? As well as device 2. But now we should be able to add it to the second box. So let's go to device 2, which is this guy, right? And we are on the second device. We will do the, where's the config? So device, again routing. And here, let's go to the static default gateway, click plus button, and here, default gateway, right? We'll add the IP address, the same IP, and the cost was 10. Hit the save. Cool. So that's what we did, right? So what we did basically till now is, you know, we basically removed the extra uplink which was there, right? So right now what we have done is technically, you know, we have created only one uplink, which is this one for, sorry, my bad. Yeah, so we have created only one uplink in this direction, which is the internet for this guy, whereas here we have one uplink, which is the MPLS, right? Earlier, and we have shut these links down. That's why we also removed, there was a static route here, or the default gateway, which we removed. And you know, here anyway, we did not have to remove the default gateway because it was coming through what? Through the DHCP anyway, right? The default gateway was coming through DHCP. Since we shut this link down, that default gateway got removed anyway. But you know, we have introduced the default gateway here. So all the traffic from this guy by default will use the MPLS transport, right? This one will use this one. Cool. So let's just check if whatever we did has gone through. Let's check one of that. One sec. All right, sorry, I paused it because I wanted to check a couple of things and in fact show you a couple of things. Like for example, since we have cut the uplinks, right? One of the uplinks on either of the side, the tunnel should have gone down, right? So if you look at BG1, if you look at WAN tunnels, you can see the tunnels through the MPLS have gone down. The one through internet will be up. Similar will be the case where with the BG2, you will have the opposite, right? So the tunnels through MPLS should be up, whereas through internet, it should have gone down, right? Because that's what we are trying to create here, right? As you see here, the through BG2 is also, yeah, it has the ones through MPLS, but the ones through internet through Verizon is down. Perfect. All right, and also maybe if we log into the CLI just to make sure, right, from BGW, if I look at show IP route, you can see there is only one default gateway now. If I get into this guy, right, and if I do show IP route, you can see the default gateway is through the MPLS, right? That's the underlay changes which have happened because we have shut down one of the uplinks and we have now maintained only one uplink per box. Perfect. Now let's do the whole, you know, the uplink sharing concept, right? So there's automation in place, so technically all of that should happen automatically, but sometimes I have seen there's a bit of an issue. So let's see, let's give it a try. Okay, so we'll start doing this. We'll basically go to the device, right? We'll do this at the device level. So let's go to the first device, right? So we'll do it at device 1, which is probably over here, right? So this is device 1. And on the device 1, where do we do this? We'll go to, we'll go to device and we'll go to config, right? Are we in the basic configuration? No, let's go to basic configuration. See, there's a section for WAN right here. Let's go on WAN. So there's something called as WAN details. Let's click on that. Okay. So this is where we will do this. So we'll click on, we'll enable the high availability, right? And then we will have to select the peer gateway, right? The peer gateway is going to be which one? The second box, correct? And we can put the peer host name, which is going to be BG2 actually. Okay. So we have done that. And then we also need to select the site, right? In our case, the site ID is what? It's optional, but we are going to go with store, right? So let's put store. Okay. That one. So we have selected the store. Then the VLAN, remember the peering VLAN is going to be 200. That's the one which we are selecting. Okay. Here we have to select the local IP is 200.1, whereas the peer IP is 200.2. Perfect. So once you have done all of that, you can hit the save settings. Okay. So once you do that, once it comes back, right? I mean, sometimes I've seen this, right? So I get this error. And though you hit the save button, you get the error saying that interface VLAN IP of local must be different. But as you saw clearly, I had put a different IP. I had put 200.2, right? But this is what, like I said, this is what I've seen happens. I'm not sure if it's something to do with, you know, uh, with the virtual device, because we're using the virtual device as a branch gateway, right? Ideally it should be used as VPNC, so maybe it's something to do with that. But the way I have found, maybe sometimes I find a solution, the solution which has worked for me is, so you can go onto the device, right? Like for example, a branch gateway, and you can look at the CLI, right? This is the CLI, which is, as you see here, it is branch gateway peer 10.200.2 interface VLAN 200. So you see the CLI has come in, right? On which device? On the branch gateway 1. But on the branch gateway 2, if you run the same command, right, you will not see that CLI, right? And that's the reason why the issue comes into play, right? So the way I have found to kind of solve this is basically, doing the reverse, right? So going into the BG2 gateway and doing the same flow once again, that sometimes, has solved the problem. So let's try to do that. So we'll go to, we'll go back, we'll go one step back, right? We'll go into BG2 now, right? Then we'll go to device. Ideally, this shouldn't be the case. I mean, you do it on one device, the configuration should go to both the devices and the peering should happen. But I'm assuming it's also something to do with we using virtual gateway, which is not supposed to be used as branch gateway. So we could go to WAN, we go to WAN details again, right? Do the same process, right? But the reverse. So here you're going to select your local gateway is going to be 2. Right, and then we can select the peer is 1, right? We will select again BGW1 is the host. Sorry, let's remove this and let's put 1, and the site ID is going to be store, right? Perfect. And the VLAN is again going to be 200. Okay, so again here the local is .2, the remote is supposed to be actually .1, correct? So you see I'm putting a different IP address, but when you hit the save button, it will normally, it will try to apply the settings. In fact, I think it is applying the settings, but it is applying it on only one box. So that's the reason the issue comes into play. But anyway, let's see if this works. I have a little bit of success rate with this approach. And there you go. See, you got the same error, but at least let's go and check if the second box got the config now. Okay, it's still not gotten it. Okay, there you go. Now it has gotten the config, right? So because it has gotten the config, I have a feeling, things should be working. So what we could do is, let's run the most important command. Let's clear the screen. It is show uplink. And there you go. We have it working, right? So you can see when you run the show uplink command, you can see there is one uplink, which is a wired uplink, which is the inet one, right? It is connected, it is in up state, everything is good, reachable. Whereas the second uplink is a virtual uplink. How did this virtual uplink come? Because it is coming through the tunnel, right? So because BG1 doesn't have direct connectivity to MPLS, it is using the tunnel to then reach out to the MPLS uplink, which is being offered by the second box. If you go and do the same thing on this guy, let's clear the screen, show uplink, and there you go, right? So this guy has a wired uplink for MPLS, whereas he's using the virtual uplink for the Verizon. Okay, so that's important, right? We can also look at some of the topology. If you want to look at the exact same thing on central, you can actually go back here, go to the store, right? And once you're there, you can click on overview, you can come on topology, and there you go. Now you have both the boxes here, right, which is good, right? And it is showing that so this box, yeah, so this box is connected to MPLS. I think technically I don't think it will show the uplink sharing, but that's fine. What we will do is we'll probably click on this guy and see what it shows. There you go, right? So let me hide this one. So because I clicked on BG1, it shows that it shows the virtual tunnels. These are the virtual tunnels which I'm talking about, right? So it has physical tunnels, or it has physical tunnels through the internet, correct? And then we can probably expand and have a look at this, right? So this is 4094, this is 4094, whereas what's happening here? So this is basically you can see it has created a separate, if you actually go into the box and look at right, let's look at that. So if you do show IP interface brief, right? So you can see that tunnel 14 is here, and you see the tunnel 14 gets one private IP which is 172.16.50.1. These are not routable IP, but for the GRE tunnel, right, this is the IP address which is basically used, right? And the tunnel will actually be on this one, this particular VLAN is the peering VLAN, but you see 172.16.50.1 and tunnel 14 is associated with the, with what? You can see tunnel 14 here as well somewhere, right? There you go, tunnel 14 associated with the virtual link. So that's what you see here as well. So that's the virtual link between the boxes, right? 50.9 and so on, right? So you can see the virtual tunnels, very much evident. So basically so right now what is happening is it has two tunnels through the, BG1 gateway has two tunnels. I'm talking about the IPsec tunnels, two IPsec tunnels going through the physical uplink, right, which are the top ones, top two, and the bottom virtual two tunnels are nothing but tunnels through MPLS, but it is going through the GRE, right, because of uplink sharing. We should be technically, we'll see the same thing if you click on BG2 as well, but the reverse, right? It will have MPLS on the top and it will use the virtual tunnels for the other one. If you go to devices again, and I think our tunnels should have been restored. We had gone down to 2, right? It should become 4 mostly. Let's check that. So if I go to BG1, if I go to WAN, right, I go to tunnels, and technically there you go. Okay, so 3 tunnels are up, maybe one of them is down. So again, this is something to do with, if I reboot the box it will come up, but that's the case over there. But you can see at least 3 tunnels are up. With the second box, which is also, I think we'll probably see 3, because I think one box is probably giving some issue, or one of the link is probably giving us some issue. Right, there you go. So at least 3 tunnels are up, right? So there you go. That's basically how you can do the whole uplink sharing. But the main way for you to verify is using the command show uplink, right? So that's the best way to verify. But like for example, here also you can verify, because we are on BG2, right? And like I said, on BG2 we are using physical uplinks for MPLS. So the first 2 should technically be up, irrespective of whatever it is. But you see these 2 tunnels are actually coming through the internet tunnels, are going actually through the uplink sharing which we just now did, right? So that's what you would actually see. You see the WAN IP here is 172.16.50.9. We have not configured this IP. The SD branch or central automatically uses this IP. It uses a private range. Anyway, it doesn't have to be routable. So yeah, but basically this is where you can come and verify that you're actually you actually have tunnels over the virtual tunnel, and it's actually it's able to kind of use the uplink sharing concept, that's working, right? Perfect. The last one is we'll do the VRRP part, right? Because we have added the second box, we need to enable VRRP, right? So let's go into the second box. Let's go into device, right? And here we could go to the advanced mode, and on the advanced mode we could go to high availability, right? So here you have the VRRP section, correct? So we'll add the plus button here, and here we will have to let's just scroll down a little bit. Yeah, so here let's start putting we'll have to create 5 instances for different VRRP, right? So let's do with 5. So the IP address would be, remember the VRRP IP is .1, right? That's what we have used. Priority, let's use 100. I think we have used higher priority on the box 1, if I'm not wrong. I think we have. So maybe we have used 120. I've forgotten. I'll probably go and check it later. But I think, yeah, so we have 100 here. Let's put 100 here. And we can enable preemption, right? Preemption delay is going to be 60 seconds. So 60 seconds, and the admin state should be up, right? The VLAN ID will be 5. So hit the save button. Same thing we'll have to do for the rest of the VLAN. So let's do it for 6, right? The VRRP IP is going to be over here, priority is going to be same 100, preemption is enabled, delay is 60, and admin state is up. Perfect. And VLAN is going to be 6. Hit the save button. Okay, next is let's go with 7, right? So the VRRP again, ID is 7. The IP address is gonna be over here, right? Priority is 100, and router, this is going to be preemption is enabled, 60 seconds, admin state is up, and this is going to be 6. Okay, so we have sorry, I think I made a mistake. So that was supposed to be, I think, 7, right? So let's edit that. This is supposed to be, the VLAN is supposed to be 7. Okay, let's hit the save. So there you go, we have 5, 6, 7, and maybe the last guy is going to be it's going to be 8, right? So the IP address is going to be .1, priority is 100, preemption is enabled, this is going to be 60 seconds, this is up, and this is going to be 8. Save. Okay, so VRRP is almost configured. VRRP is just the most common way to give you redundancy, right? So now you can have your gateways on both the boxes, and based on the VRRP configuration, even if one of the box goes down, the other box can take over the traffic and become the default gateway. So we have 5678, 5678 IP addresses look good, everything is up, right? So it would probably take a little bit of time, I guess. For meanwhile, let's go and check what we have on BG1, right? I forgot what is the priority which we have given. Is BG1 supposed to be the active? I've forgotten. Let's look at it. So we'll go to this guy. Let's go to device, right? Let's go to it's fine, advanced mode, high availability, and here if I click on one of this guy, you see, okay, the priority is 200. So we intend to make the BG1 as the active or the master, whereas the other guy is going to be the standby. So if I go to my CLI now, so if I look at BG1, show VRRP, you can see it is master, right? So all of this is master, all the four instances it is master. If you go to the second BG2, which is not responsive, let's try to do it, disconnect. Okay, sometimes that happens, 1 sec. Okay, looks like my port forwarding is stuck. So what I can do is probably show it to you on the VNC itself, right? So there you go. So that's my VNC, and if I probably again run the command, show VRRP, and you can see it's all backup, right? 5, 6, 7, 8, everywhere it is a backup. So the sync has completed and the VRRP is working, whereas the master is your gateway 1 and your standby is your gateway 2. Okay, so okay, anyway, so yeah, that's my screen again. There you go. So VRRP worked. I think that kind of completes everything we wanted to do. Let's kind of now do a quick recap of everything we have done, right? Just to kind of make sure that we wind up with on a good note here, right? We can grasp everything what we did, right? So coming back, let's use my pen. Okay. So to start with, like I said, in the very first video we started with the introduction. We tried to understand a very basic understanding of what the solution is all about, right? Only thing you need to remember here is the underlay is you just need to bring up the underlay, right? When I say underlay, you just need to bring up the connectivity between all the boxes, right? Actually, let's do it this way, right? So let's start with what we really did on every video, right? So we started with we did an introduction of the solution, then we talked about the topology, right? We talked about the topology. So if you want to kind of do that, go back to the first video and you can check that out. In the second video, what we did was we brought up the branch gateway. So we brought up this particular one device, right? We configured the uplinks, we configured the LAN side, and we did a bunch of configurations on the box, but ultimately we brought this up, we connected it to the central, we created the group required, and we made sure everything was looking good from this box. In the third video, we brought up these two guys, right, the VPNCs. We had used the ZTP approach here, right? So we used for this one we used the static activate approach, right? The static way or bootstrapping way, right? We manually put the IP address, DNS server, default IP, and the VPNC came up, went and connected to central. We created the group on central. It pulled the right configuration, and the VPNCs were up. Okay. After that, we started creating the underlay routing. Now this is very important, right? So if you are deploying the SD branch, right, I would suggest you to look at the flow which we followed, because that's how you would be doing the deployment as well. So once you brought up the boxes, then the next very important thing for you to do is make sure that there is connectivity, right? There is connectivity between all these uplinks, right? Or basically there is connectivity between all the uplinks, right? So that you ultimately you can run tunnels on top of it. So having the underlay routing is very important. It can be anything. You can use static routes, you can use BGP, whatever, right? But having the underlay routing is very important between between the like-minded transports, right? Between this internet and this internet interface, between this MPLS and this MPLS interface. Similarly with the other VPNC as well, right? The tunnels are going to be formed from the branch gateway to every VPNC, because we are using a hub and spoke type of a topology here. So that was the next thing which we did, right? So we did the underlay routing. We again played around with different types of routing here, right? We used static routing. We used the default gateways on one side. We configured BGP here, right? We explored eBGP, iBGP. We did play around with communities. We used communities to make a particular AS, or we made the VPNC as non-transit device and things like that, right? You can go back and check that. Now once we had the underlay, the very next thing we did was in case of SD branch, we have a centralized control plane, right? We have a centralized control plane, and this is cloud hosted, right? So what we did was we went and told the control plane, or basically in other words, you will also see people calling this as tunnel orchestrator or route orchestrator, right? Which is there on the cloud, which is there on the central. So what we did was we basically tagged the interfaces with the correct transport type. For example, here we tagged this with internet, we tagged this interface with the MPLS, and so on. We did it on all the devices. So by doing that, and then we initiated the orchestration, which means all the tunnels started coming up, right? So the control tunnels and the data tunnels. The data tunnels are basically the IPsec tunnels between every transport, like from here to here, which is the internet. And then you had via the MPLS you had the second tunnel like this. Similarly for the other guy as well, through internet we had this tunnel, and then through MPLS we had the second tunnel like this. So those were the IPsec data tunnels. Next we also need is the MPLS tunnels. We need the control tunnels, right? So you have Aruba Central, and you have the route orchestrator over there, right? So remember we spoke about this. We have the OAP protocol, right, which is running between these guys. Just like we had OMP in case of SD-WAN, here we have the OAP protocol. Why you need this OAP protocol? Because this is going to be the control plane, right? The overlay control plane. So once you have this connectivity, or the OAP tunnels or the control plane setup with the centralized orchestrator which is residing on the cloud, what you can do now is you can send these routes, right? Either it is from BGP or connected or static routes, you can redistribute it here, and then it is going to, let's use a different pen, right? So once you redistribute, it is going to come here, and from here the route orchestrator will reflect those routes to all the other sites, right? So same thing here as well, right? So the routes came in here, and then it got reflected here, right? So because it got reflected, now we basically had the spoke was having connectivity to all these subnets, right? So it gets redistributed here, and from here we can again redistribute it. I mean it comes on it gets learned on the overlay, and from there you can redistribute it into whatever IGP you're running here, right? So that's what we did, right? So that was the basic crust, and this is pretty much common in most of the SD-WAN solutions. This is how it works, right? Only difference would be in case of Cisco's SD-WAN, we had a dedicated control plane device, like we had something called as vSmart, whereas here we have the control plane running on the cloud in Aruba Central. So you don't really need to run a separate appliance. You don't have to maintain it. It is running on the cloud. All you have to do is, just turn on the knob, and the devices will form the control channel to it. And you just need to take your subnets or your routes, and advertise it or redistribute it into that overlay, so that the overlay will learn it and then it will send it to the other sites, right? And again, remember, we are using the hub and spoke topology here, right? So the routes from the hubs and spokes are basically learned in the very hub and spoke kind of a fashion. That is not going to be, if you have one more branch here, you're not going to have branch to branch connectivity unless you do something like branch mesh and stuff. Otherwise, all the traffic will go through the hub and then go to the other branch. Okay, cool. So that's what we did with the control overlay control plane. Next, we started playing around with the data plane. Again, data plane, which is the overlay data plane, right? Once you had the tunnels, once you had the IPsec tunnels, right, you need to kind of figure out how you can influence the traffic on those tunnels. So that's where we did two things. One is PBR, right? So we did PBR where we kind of, based on certain matching criteria, we selected which uplink we want, right? Which next hop we want, in fact, right? So we kind of explored that, we verified that it was all working. The next is we also did DPS, right? Which is very much similar to application aware routing. We created SLAs, right? We created specific SLAs and we made sure the traffic went on the link which can meet the SLAs. Perfect. So all of that was done, and finally we did redundancy, right? Branch redundancy. We brought up the second branch gateway. We kind of once we brought up the second branch gateway, we went and shut these links, right? Because we wanted to explore what will happen if I have just one uplink, right? If I have this one uplink, right? Because that's a possible case, right? You might have a scenario where your provider, you have not taken two uplinks, right? Because every single uplink you take from the provider is going to add to your cost. So what if you take one uplink from the internet and one uplink from the MPLS? Then you can use the concept of sharing. You can share that uplink, and even if this guy doesn't have the MPLS uplink, you can create a GRE tunnel between these guys and you can send the traffic over the GRE tunnel and share it in that way, right? So we did the same thing on both the directions. And finally, what we did was we set up VRRP. VRRP was already set up. All we did was we added VRRP configuration to the second box and we made sure that this was the master, this was the standby. Perfect. So we did quite a lot of exercises. Technically we kind of brought up the whole, a very simple hub and spoke branch, site. This is the workflow you would normally follow as well. Now there are obviously a lot of other features, especially with the physical hardware boxes. You can do IDS, IPS, you can do clustering and all of those fun things. So do check those things out. And if I have time, maybe I'll cover some of that in future. But until then, thanks for watching. Stay safe. Bye-bye.